to cover a variety of different kinds of megachilids, some of the more obscure ones, but we'll start with the least of the more common of the more obscure ones. Does that make sense? I'm not sure. Which is Coelioxys. So Coelioxys is a very easy to identify. Gosh, if they were only all that easy to identify, nest parasite. So it's a parasitic member of Megachilidae. If you get one, oh, I've got an error. Are we still?
We can see your camera.
Okay,
so.
good. So if you get one, a giveaway, in addition to the super obvious characters we'll talk about in a second, is that the compound eyes have, let's see, oh, you know what? I don't know if my screen, my screen, I just got that error message. I am not
able. Microscope clearly.
Yeah, but you can't. I'm moving the specimen and it is not showing up.
Oh, that is no. You just see the
let's see. It gave me an error. I've got the little button in. I'm going to turn this off and on and see if it comes back to life. Okay, and I'm going to do the acquire again. And I may have to, I'm going to now turn this program off and back on. This is the microscope that has been a loaner from, well, let me concentrate and on this. From the Forest Service, thank you, Craig. And so we need to go to that and then to elements. Should start up. Yeah, it said live feed was not enabled. I've got it. I may not be completely, hold on. Okay. Just changing my network cable, make sure it's in. There we go, and I'm going to say okay on that. Sorry about this. Anyway, there's tiny short hairs on the eyeballs of Coelioxys. So the only other group that really has that is are the honeybees, so Apis, and they have long hairs. And you often don't notice these in Coelioxys, but if you look closely, they all have very a fur-like membrane of hairs, not a membrane, a rug of hairs on their eyes. But there's several other very easy to see characters. Okay, now we're going to try this again. Back to acquire and live view, and we're in. Good. Okay, thank goodness. Hopefully it will stay that way. So we were just showing here a shot of the hairs. I'm going to rotate the magnification through slowly, and if you look at the upper part, you can see the hairs in profile. We don't really need to see them because we're looking at a female right here, and the combination, well, actually, all you have to do is look at the rear end. So this pointed, almost triangular shaped body is present in all the females, and it comes to a sharp tip, and that sharp tip is used to inject its eggs into the nests of megachilids of different kinds. Yeah, there's quite a few Coelioxys because there's quite a few megachili, which it mostly parasitizes. I'm not sure if it probably does. There's probably species that parasitize other things other than megachili. Additionally, it's got the traditional 2 submarginal cells. To get my little piece of paper here to show that better. So we have, as you've seen many times now, marginal cell, submarginal cells, and there's always 2, as there are in many of the megachilidae groups. And you can, well, look at the axilla. It's not something that completely defines it, but it's useful in looking at the characters of Megachilidae, what's going on the scutellum. So in this case, this is Coelioxys germana, and it's a very easy to tell species within Coelioxys because at least in the east, it's the only one with this projecting central spine coming out. These are the axilla, and if you remember, the axilla on a bee are actually a separate plate. You can't see the suture line here, but it's separate from this scutellum. And in a few species, a few genera rather, these axilla are projecting out. For what reason, I'm not sure, and form points. Coelioxys is one of the few there, and it's another nice character to see. But the pointed triangular abdomen is the key, and you know right away you have a female. And we'll switch now to a male, and you'll see at the species level, there's lots of other really nice characters to work with in Coelioxys. But then, of course, there's always several pairs of closely related species that are troublesome. So, in general, same thing with hairy eyeballs. You've got a scutellum with the projecting points off also in the male. Here's another Germana, so it also has the lovely species-specific central spine or projection on the scutellum sticking out. So always with the two submarginals. And then in the back end, there is some variation of this theme where there are, let me just zoom in on there, a bunch of projecting things that one sometimes might want to call points and sometimes might want to call plates. They vary by species, and I'm just going to rotate the, I'm just going to put my cursor to one side. I'm going to rotate the focus through there. There's usually about 8 on there, and they're fairly species specific, but in species ID, they're not used that often because it's difficult to describe exactly these patterns. And so this should be T7, and T6 also has spines on the side too. Not used that often in ID, but in terms of identifying the genus, this architecture of the rear end is definitive. So they all have some variation on that type of thing. So you can almost always right away tell that you're looking at a Coelioxys. And if you really have a question, which you would rarely probably do, you can always go to the eyes and see if the tiny hairs are sticking out of the eyeballs. All right, so now let's jump right to some of the most problematic genera, because the characters in particularly, well, I think Discover Life uses a lot of Michener's characters, and we've modified some, including these, and we could use some advice probably if you were confused by them so that we can do a better job of talking about it. But we're going to look at Paranthidium and Stelis. So Paranthidium is a pollen gathering group of bees. In the east, there's only one. I think there might be one more species in the United States in the southwest, but I'm not sure about that. In the east, it's a pretty much a bee restricted to gathering pollen only from woodland sunflowers. Not sure what the western populations feed on, but almost certainly it would be something in that composite late season group of plants. If indeed it may also be a helianthus, a woodland sunflower. Helianthus is just a really a plant that you should always be thinking about when doing restoration work, and you know, and what's in a landscape, because there's so many bees that use Helianthus. So here
Real
is,
quick,
yeah.
We have two general questions.
Okay.
Regarding Coelioxys, just a confirmation, the abdomen in males is also pointed, but differs from females in the shape of the ending.
Yes. So the shape of the abdomen in the males in Coelioxys is elongated, but it doesn't come to that one sharp point, which is even more elongate than in the males. In the females are using that to slice into the nest walls. So it's unusually long and unusually pointed. The males have, if you were to draw out the shape of that abdomen, I would say it's a little more truncate, but probably longer than most other species, but its relative length to width I don't think is as dramatically obvious as the females. And it's all about, I think the most obvious thing for the males is, and we've got quite a few in the collection, so if there's a little spot of time, I can show several more rear ends, so to speak, of males of different species. But they always have that, I'll say, 6 to 8 spined look to the end, where, and it's quite dramatic. I mean, these are not like subtle things like in Melisodes or whatnot. They're big and they're obvious, and there's never hair on them in enough density to block their view. Does that sound good?
I think that's good. Also, how many abdominal segments do males and females have?
The visible, so there's some abdominal segments, and again, I'm not sure if they're visible or even present in the tergites, let's call it. The tergites would be the top abdominal segments. The sternites are the underside of the abdomen. And in, I think, most species, it goes up to eight abdominal segments in the males, and then in the females, I believe it's fewer in the sternites. So on the tergites, though, the pattern in almost all cases is going to be 6 tergites for females and 7 tergites for males. You have to be careful sometimes because things can be retracted, like the abdomen can be pulled in to some extent, and so the last 2 can be hard to see, but almost always you can spot that pattern. But with Coelioxys is a good example. You can always use antennal segments. So 12 in females, 13 in males, and that tends to be my go-to characteristic, unless there's something about that genus that I know is present only in the males or only in the females. But if I have questions, I always count the antennal segments, assuming they're there. Okay, so now what we're looking at is Paranthidium jugatorium. So this is an Anthidiine, so it's in that Anthidium, Anthidiellum group. And like many, it has bold black and yellow markings. And we'll see another set of, oh no, sorry, I'm sorry about Paranthidium, I'm already jumping to Stelis. But this model of pattern in yellow and black is also present in Anthidium, Anthidiellum, Stelis, in some cases of Stelis. So there are differences, and in our guide to the bee genera of Maryland, which is designed to be used with binoculars, you can just use the patterns in the face to tell the different genera apart. So, but we're not concentrating on that. We'll concentrate on the fact that and you can see that right there, we're going to look at that and say, oh, you know what, there is no aurolium or pad between the toes in this specimen of Paranthidium. And that's going to separate it from Anthidium species who have a, sorry, I'm backing up. Oh, wait a minute. Okay, now I'm confusing myself. Does it have an aurolium? It looks like it doesn't have an aurolium. So Anthidium doesn't have an aurolium. Does Paranthidium not have an aurolium? All right, I've got to check myself here. So Paranthidium, on the female, it says aurolium present. And then we'll look at the spines here. Let's just make sure I pulled the right specimen. Okay, I did. So theoretically, there's an aurolium there, although it doesn't look like there's an aurolium there. So let me change the position on this specimen and see if an aurolium is not dangling out on that, between those toes. From that direction, which, you know, again, we're seeing, oh, there we go. Look, there's an aurolium showing up. So I'll try and zoom in a bit more.
That segues nicely from our class last time where we were asking about teeny tiny ones.
Yeah, and so I think this is actually just projecting downward. So as I emphasize, when you're working with specimens, we're putting them into clay in this class, but you want to be holding them in your hand so you can subtly, with your fingers and your hands forming a nice base on the stage of the microscope, you want to be doing that so you can subtly move the specimen around to look for, like, oh, did I, because that first shot, it did not look like it had an aurolium. But once I bent it another way, you can see that the aurolium basically is there and bent over. So, all right, disaster averted, whatever that means in taxonomy. It's got an aurolium, so that separates it from Anthidiums. This is a female, and the number of teeth, I can't remember the exact number of teeth. I think there's 4, which in Anthidium is often, you know, like 10. So that is a useful character. Let's take a look how many they have. There's the teeth on the mandible, and so usually that'd be 1 at the corner, 2, 3, 4. It looks like it is 4. You can get wear in the mandibles sometimes, and it makes it difficult to see.
Before you move away from the face, can you zoom out and clarify so I can take a screenshot of the facial pattern?
Yep. Let me get it in focus here. All right.
Looks good. Can I take a picture?
Okay, so if the main character, and I'm going to jump to the B memorization chart here to make sure that we get everything. I'm going to make sure we're on Paranthidium. And again, if you don't have this, Clare has it up on the file site for the webinar, or we can email it to you. So going through the fairly long characters here for Paranthidium, 2 submarginal cells, they all have that. Yellow, white, or actually, I shouldn't say that, most have that. Yellow, white, or ochre markings on the tergites, check. Aurolium present, yes. Front and middle tibia without any outer spine. This is the tricky thing we're going to look at, because that's what Stelis has, and there is a Stelis lewisiae, which we're going to look at, that looks almost exactly like the Paranthidium. And the outer and the apical end of the tibia has a broad projection with a round tip that slightly but clearly projects beyond the surface hairs to be 2 or more times those hairs' length on the surface of the tibia. Okay, we're going to look at that because that's a long sentence, or a sentence segment, as my English teacher would have said to me in 5th grade, which I failed. Behind this projection is a hairless, shining, scoop-like area. Mandibles broaden apically and has 4 teeth. Lateral and anterior faces smooth, transition without a carina or abrupt angle. That's lateral, I should say, lateral and anterior faces of the thorax, and that separates it from, I'm pretty sure, Dianthidium and maybe a Western genus too. That's the normal state, so there's usually no sharp angle. If we have time today, we'll pull out a Dianthidium. Okay, so, and the tegula is normal. Now, if we go back here and we can look at some of these things. In particular, we're going to, everything makes the most sense except for these tibia characters. And this is going to be classically what you would have to be looking at when you are looking for differences between in Stelis and Paranthidium, is you're going to end up having to deal with this if you're using a dichotomous key. Later, you'll just have everything memorized and you'll know it by sight. But Paranthidium is a rare, on the rare end of the spectrum, in terms of it's just not often come across in collections or in collecting. So you will only see a few in most cases, or none. So here we are looking at the front tibia and the middle tibia. Same would be basically true on the rear. And we'll try some different angles. So down here in Stelis, and you'll see nice examples of this, there would be 2 projecting spurs. So spurs are things that are long and narrow, but not hairs. And so they're part of the integument pulled out. In Paranthidium, you don't have that. What you do have is this scoop-like or rounded projecting plate, lamellate, they might call it, thin projecting out from the end of the tibia thing. And let's see if we can get a different angle on this.
Before you do, let me take a picture.
Okay.
Can you sharpen it a little bit?
Yeah, let me zoom in here and we'll go to this middle one. See a little bit of hair or fiber on there. So that would be it right there. And let's look at it at a slightly different angle.
I got the picture.
Okay, did you get it? Sorry. Okay. And we are there again, but just at a slightly more oblique angle. So I'm just pointing out, this is the scoop-like area, no spurs. And when we look over here, same thing. It's broadly rounded on the edge. It's fairly wide, you know, in comparison to the width of the overall end of the tibia. It's fairly wide, and you have this thing going on. It's relatively difficult to describe that, and looking at it is so much nicer. Okay, so additionally in the female, and sadly I don't have any males, but the characters are roughly the same. You have pollen-carrying hairs underneath. It is megacoelides, so the pollen-carrying hairs are underneath. This specimen is, the hairs are very clumped together because of whatever washing issues it had, but you can see the long hairs that be used for carrying pollen underneath there. All right, so now let's jump to Stelis. So there's really effectively only one species we have to worry about there, and it looks like that. But often, since you're not seeing it very much, your first conclusion is to jump to probably to Anthidium and then to Stelis. But
let's confirm if there are pollen-carrying hairs found on the males.
Not so. Males don't move pollen around. They inadvert on purpose, right? So they're not provisioning a nest. No, I know of no male that actually helps with provisioning of any nest of any bee. So they often, though, have a reflection of the female's architecture, which is much more important because the female has to move the pollen and has to make the nest and basically do everything. So a lot of times that means that males can have a relatively large amount of hair and may inadvertently pick up pollen when they visit plants, as do many other insects like wasps and flies and things, which are targeted by many of the plants. And so they're not, so bees are doing it from an objective fashion that they want that pollen and they're going to feed it to their babies. And sometimes they take a little snack of it themselves. So it's quite a different strategy than for a plant than bees, wasps, and flies and other things that just happen to land on the plant and they're trying to glue some pollen to them. So I hope that explains things well enough. All right, so now I'm going to move to Stelis. So Stelis, there's several groups of Stelis, and they look, within those groups, they look quite different. They're given subgenera status, and sometimes they're given full genera status. So right now, all these groups in our parlance, and we largely are following John Asher's advice. Sometimes we're a little bit behind. Is going to be all Stelis, not separated into separate things. But you can see that the vibe. So these are within the Anthidiinae group of Megachilidae, but these are all species that are nest parasites. So they are, and this is another reason that they often think of them as more than one genus. Some are nest parasites on Osmia, and those tend to be small and dark. And then the others, like these, are often nest parasites on Megachilidae. But you can see how similar it looks to the species we just were looking at, the Paranthidium. So there's color patterns, so you can look at color patterns here and tell differences in them. But the technical difference, so this is actually the species that people come across that most looks like the Paranthidium and may cause some troubles. So, but in a female, you would notice right away that, and we have, again, only females here, sadly. In the females, you would notice that it is a female based on your counts of hair, of antennal segments and abdominal segments, and that there's no buildup of long hairs here underneath that would be the scopal or pollen-carrying hairs. But if we zoom in, you can see there are, this is one of the problems, right? There are a lot of hairs there, and if you don't have a broad range of experience, you might say, well, those could be pollen-carrying hairs, but they're not. They're just the male version of a female-like character. So there's a few longer hairs there, but not in the density that would help the male or carry pollen. Not that it ever would. And actually, what am I saying? So I'm confusing two things here again. So there still are long hairs here, but this is the female, and she is not gathering pollen because she is a nest parasite. So ignore what I was talking about in terms of that males are a reflection of females, which they are, but in this case, there's still long hairs here, but not in that density we saw in the last one, and the thickness and size of the hairs there indicating that it could carry pollen. But it's still, it could be a little confusing because that, maybe that is carrying hairs or carrying pollen. Certainly we see very small amounts of hair on some specialist bees that are on Oenothera, so evening primroses, for example, and they strip their pollen-carrying hairs way down. But in this case, it is not. So now, so it also has, I believe, in Stelis, it also has a rholium and has two submarginal cells. So you can tell them from Anthidiums, and it doesn't have the long plate that the female on the back of the scutellum, so you can tell it from Anthidiellum. But now we're going to look at the infamous two CT, or spurs, sometimes they're called. Not CT, two spurs. Did I say CT the other time? CT would be a hair. And we're looking for spurs, which are projections of the, let me dial this back to get a good shot of it. So there's a broken leg here that we're going to exploit for seeing, hopefully, for seeing the hairs. I mean the spurs. Let me get a good shot there. Okay, well, while we're looking at the front leg, this is the area. Here's the tibia, here's the tip. You can see one spur there. There's almost no hair nicely in this one. So these are the projecting spurs, which are different from the so these are different, and in addition to the traditional tibial spurs that occur underneath, these are on top. This is why it's so confusing sometimes. Okay, now we're going to move to the middle one, and we should be able to see this more readily.
So while we usually look at legs, the rear legs or like front coxa, these are available on every leg?
I believe that to be the case, yes. Usually you end up on these looking at the middle leg because it's just more conveniently set up. Okay, this one, so here's the tibia on this one, but the tarsal segments that come after are broken off. So theoretically, when I was looking at it under the microscope myself, it seemed easier to see these things. Let's see if I can get you to see what I was seeing. So there's two, it's not super clear, is it? So here's the normal tibial spur, and then there's these projecting spurs or integument above. Let's.
Can I do it by the side?
I'm going to flip this side. I'm going to go to the Genera cheat sheet right now and see what the lingo on these is, whether they're calling them spurs or not. So you see Stelis is right there next to it, and we are and mandibles. Oh, that one does not. Oh, I guess because it's a female, it's easy to tell apart. The males, I guess, are the more difficult ones. So middle tibia, although, yeah, so here it's just talking about the middle tibia with two, which I guess possibly means that the other front and rear legs don't have this, or maybe this is just the most careful. With two apical spines, so middle tibia with two apical spines, and in some of these, and we'll see the dark Stelis that are osmia specialists next, and you can see that it's really difficult to see these apical spines, and that there's a note that there's almost always at least some pale markings on the abdomen, often extensive. So
in Discover Life, the middle tibia with two spines at end nearest tarsi on outer side.
Okay.
If for small specimens, examine from top.
All right, so let's see if we can go back here. So it's only on the middle tarsi. So we do have the middle tarsi here. That's not showing well, but let's tip it a little further. Dial it down so I can get a good shot of this. And okay, there's our broken off. Oh, you can see one now. So you can see the typical spur that's on the ventral side, or the bottom side there, sticking way out. And okay, I think we've got it here. So that's the spur, the tibial spur. I think most bees have them. And here are the two projecting spines, maybe they're calling them, rather than spurs. So there's one right there, and then there's the other. So the thing to look at here is the difference between what you saw in Paranthidium, where this is the same area, but there's these broad, we call them scoop-like things because the underside is hollow and hollowed out, but it's broad and rounded. And here there are spine-like tips. Don't confuse it with the tibial spur, though, at the end of the middle tibia. So, but the thing is, and the thing to keep in mind is that the genus Stelis, as discussed now, is very diverse in its look. So I'm going to pull another specimen, and this is the very most common Stelis in the East, which is Stelis lateralis. Stelis louisiae attacks if that's an appropriate word, attacks the resin-using megachile like Exilus and Campanuli. So let's find Stelis lateralis and pull its labels off here. And if we look, we're just going to do a habitus shot. So totally different look in terms of coloration on these things, and you don't have any of the yellows, and you have a dark looking bee. And as many in this group have, this is not showing up on this specimen very well, but when we turn it on the side, you'll see that there's a series of cream colored spots on the lateral sides. Maybe that's why it's called lateralis. And in the females, there'll be no scopal hairs, so you can use that fact and the other megachile kinds of characters to separate it from the other members of the group. But the key to Stelis in the males, at least, and also, can be used in the females, would be these spines, which are just this is a really, first of all, it's very small, and there's more hair on the legs here, but you can see here so this is the basotarsus tarsal segments, two spines there and there at the ends of the tibia. Am I looking at the tibia, or am I looking? No, that was, sorry, bad. Maybe they also have it on the femur. That was the femur. There's the tibia. And then below that is the basotarsus. So there are the two spines. I wonder if it has it on both. I don't know. But I'll move this more to the center here. So spine 1, spine 2, and then underneath here would be a tibial spur. So actually, I'm surprised how well we can see it in this small, dark Stelis specimen. Let's turn this on its side.
Sam, can you remind the class what species you're looking at?
This is Stelis lateralis. So it's a nest parasite of Osmia, and I think it's known from Osmia pumila and Atraventris. So again, almost entirely black and doesn't have any other real modifications. There's no pollen-carrying hairs because this is a female on the underside. And it doesn't show because we're looking through the wings well, but these are pale cream markings on the lateral sides of this specimen. And the males also have that. And let's see if we can see it better on this side. Yeah, so you can see. So often for Stelis lateralis, you can just see that general pattern with black and these lateral side spots, and you have a really strong indicator that it's going to be Stelis and probably lateralis. It's by far the most common. And you see no scopal hairs under here on the underside of the abdomen. Let's see if we can see. I'm going to check again to see if we see on the middle leg those spines, because it's always the one that people have a hard time finding. Sometimes in these hairier ones you have to, or if it's goopy, you have to run a pin tip through that while you're looking on the microscope. See, I'm not resolving this well enough to tell you what's going on, to see that character. So that was a fail in terms of seeing the character, but those are the two extremes. And even within the species, you can get quite a bit of variation in where the markings are and sizes. And in the males, but sadly I don't have, they often have, I think it's the males, some members of these groups have really, I think males have really weird modified rear ends. I guess the sternites, but I'd have to go back and look. I see them so uncommon. These are really uncommon bee genera that I can't give you a lot more hints on that. Okay, now let's run and jump to Heriades. And Heriades is a small group of bees that largely are nesting in tiny holes in wood made by wood-boring beetles. They're small enough that I think a lot of times they're inhabiting some of the pesky wood-boring beetles like powder post beetles and those kinds of things.
Before we dig into Heriades, are Stelis in general small bees?
I would say that the Stelis I was just showing, Stelis lateralis, is smaller than the smallest osmia. So that's pretty small. But some of the other Stelis, are possibly up to the size of somewhere, let's say, half the size of a honeybee. So that's kind of the range between the two.
And this is also a 10-minute warning.
Okay, so we're looking at Heriades here. And Heriades are heavily armored bees, beautifully sculptured, but very similar in ways to that black Paranthidium that we saw before. It's going to have two submarginal cells. I have other examples here of the females, but maybe I don't. Well, I should in this batch. Where's the Heriades? There we go. Anyway, heavily armored, heavily pitted, very small, and then the key character here, and also within Megachilidae, you have a group of bees that here at the propodium are, we'll change the view here, are a series of pits, large square pits throughout that area, rather than some kind of smoothed over segment often with little striations like in Helichtidae. But here, those are big open pits. But the key character is on the first tergite of the abdomen, which is here. It's very dark bee, so I'm not sure that I'm showing this super well, but we'll change the magnification. And there is a raised line, so The integument is raised up. It would be called a carina in technical terms. That is right along the edge. So there's a noticeable raised ridge, raised line, whatever you want to call it, that goes around the outer part of that segment. And the inside is, I think, always shiny. Let's see if we can get some more light in there. When I zoom it up, and you can see a little bit of the raised line here. We'll change that. That's the key character, though. Let's see if changing light does anything. A little bit right through there. Let me change let's change the lighting. You can see when I fluctuate the light, the raised area to some extent. So now let's just change the view on that.
Are all Heriades that heavily pitted?
All the ones I'm aware of, and I've seen a few European ones too, and they are heavily pitted. They must, I think of these pits here as sting deflectors. It's quite a thick integument too. So if you imagine, like, I'm another insect that I want to sting you, that these things can deflect the sting away. At least that's the story I tell. It's probably some kind of relevance to DARPA and body armor, if you were to think about it. But I guess we don't use swords anymore, do we? So if you were in sword play, you would want to have a body armor shaped like Heriades.
When you are done with this, if you would zoom out a smidge,
okay,
so I could take a screenshot of the Paranthidium and T1 together.
Okay, so here, just to show you on screen, here's that line. It's raised, it's all around. Most of the other genera, this whole area is going to be transitioned over smoothly. There's not going to be any abrupt change, and there's not going to be a line that defines, a raised line that defines those two angles to the segment. This interior is hard to see because it's dark, but it's shiny. Here again are these pits, these large pits, and we'll back out and see if we can get a shot. All the white in the background is really blowing out the camera. So for Claire to take a picture, so something like that, Claire? Okay. So you can see on the Paranthidium, which is facing the T1, all the line of pits there. And then over here, you can see the strong carina. The strong carina just is the giveaway on this. I believe this is a male specimen. And let's look underneath. So if it was a female, it carries pollen. You would see pollen carrying hairs. And the male, just to show you, or is this a female? No, it's a male. So in the female, there's just basically that those pollen-carrying hairs, almost always bright white. In the male, they have interesting architecture here on the first sternite. Often in this group, in the males and as well as the females, they'll curl up the abdomen. So you can see these last segments just basically curl over, and sometimes so much so that you can't see anything underneath the abdomen, which is sad because there's good characters there. So the males often have some kind of projecting out shield-like structure on, is that S1 or S2? Maybe that's S2 that we use its shape to identify it. But because it's so often hidden, there's a common pair, levity and variolosis, the endings may be wrong, that I can't tell apart unless that abdomen is uncurled, and you can clearly see this. A lot of times there's legs are crossed over. The pin, if you're gluing your specimen, a lot of times the specimen will be glued such that the pin is traversing right at that segment too. So there's a lot of reasons that this species ends up being a Levity versus Variolosa. And in the females, I can't tell the two apart. Pardon?
I was wrong. Well, S1 and S2 depends.
Okay, so it's in the guide, some of those first segments. So are we, let's see, let me see if I have a female in here, because I know we're running out of time. And there, oddly, I will tell you as I'm getting this one prepared, I ran into, in 2015, in Western Maryland, a set of 2 male and 1 female, or 1 female and 2 male, I'm not sure which, species, oh, that's a male too, of Heriades truncora, which is a dirt ball species, but European. And I sent it off, got it, did due diligence, got it identified. These are all males. Anyway, you have to trust me that there are hairs underneath that are dangling that carry pollen just like the other species. Anyway, we've never seen them again since. It seems illogical that they would have been there. Me happen to be in some obscure old dumping ground near Hagerstown, Maryland, catch these bees, and that they weren't already established somehow. But apparently that is the case, because they have not been seen again. So it'll be interesting. Anyway, keep your eyes open.
Why are they so armored when they aren't parasites?
It's hard to say. So it may be the case that they run into things, let's say, dangerous things in the nest that they are trying to inhabit. But I don't really know. Maybe there's some particularly ugly cuckoo wasps that they do battle with.
And to confirm, you're talking about ventroscopal hairs.
Yeah. Yeah, all Megachilidae have their scopal hairs, or their pollen-carrying hairs, on the underside of their abdomen. All right, so, this is chelostoma. We'll cover that next time, because there's some nuance to chelostoma, and given that we're running out of time, that we still have several things like Paranthidium and Tracusa, if I can find some specimens in Megachilidae to cover next time. But
okay.
We're making progress.
Yeah. Do you have any other questions that didn't make it into the chat yet? I'm going to share is we regularly get Xylocopa in the UK, but that are imported in wood but don't get established populations.
Yeah, so Xylocopa seem to be able to jump around quite a bit, because people are moving lumber and pallets and other plant material that has the nests in them. So they've shown up, Western species have shown up in Florida, and may be established of at least 2 species. And I know that Jack Neff has noticed this in firewood being moved around in Texas.
Okay. Just 2 things as we wrap up. No more questions, but I put in the chat again. I need to highlight it to actually read it for anybody who came in late. Rob Jean and Mike Arducer will be hosting a bee horse early 2022, COVID pending. Information was shared on the bee monitoring listserv. If you're not a member yet, you should join. Email me and Sam. But the information is also in the chat. Yes. Oh, and then there was a great suggestion that I find a way, either just in the chat as we go, but maybe in follow-up emails, or if we know ahead of time exactly what bees will get through, putting that on the screen, so everyone is quite certain what is happening. But you can always ask in the chat if you get lost. I'm going to stop recording. I think that's all we have today.
Okay.